Hello, and welcome in today's lecture that we will be discussing on this linked list, and we will be moving on with the bit medium problems that you know takes consideration of all the stuff that we learned in the previous classes. So this was it, just a small recap. What did we learn? We learned about the concepts that linked list involves and revolves around, the usages, the advantages that it has over arrays and stuff. Then we moved on to learn about some types of linked list. And if you guys have, uh, you know, either learned it in class or have checked it somewhere, that there are different types of linked list, and these are some of the combinations that we can apply and make our particular data structure based on our requirements, right? Then we moved on to have a problem that was on reversed linked list that involves reversing the arrows and putting the head pointer at the backward position. Then we learned how to merge two sorted linked lists. So this is the way we used. We had iterative as well as the recursive algorithms to merge two lists, right? We saw the recursive trees. Then we moved on to tackle a question that was involving cycles, right? That whether or not the linked list contained a cycle within it. So we involved having a set to check duplicates on nodes, particular nodes, and this is how we checked. Then we also had this fast and slow moving pointers concept, which is also applicable in many linked list questions. So this was one of the things, right? Today, what we'll be discussing on is a new problem that is reordering. If you check here, it's a reordering list, reorder linked list. We had two more questions to be discussed today, but I think we won't be able to discuss that today due to certain circumstances. But this is the question that we'll be looking on, and let's see what this is. Okay, एक ही सीखेंगे, but yeah. So as usual, I am putting this there, reorder list. So you're given a head of a singly linked list. The list can be represented as, you see, these are the indexes you can consider these as indexes, right? The 0th index, the first index, and it goes on, so on and so forth till the nth index. So the size of the linked list is n plus 1 if you like think, because it starts from 0th index. So what do we need to do is reorder the list to be on the following form, that is L0, Ln, L1, Ln minus 1, and so on. So what it basically tells us to do is something like this. Suppose we have a linked list in this form, that is 1, then it points to 2, then it points to 3, then this points to 4. Now what we are told to do is after L0, Ln should come. So if this is 0, this is 1, this is 2, and this is 3, so this is nth position, right? So what we need to do is after 1, 4 should come. So this should come after, and we need to remove this, right? This should come after, so this 4 comes here. Okay. Now after 4, what should come? The first position, that is this. So after 4th, this should come. Okay. So see, there are three operations in one go. That is removing the connection from 1 to 2, joining 1 and 4, joining 4 and 2. Okay. So then 4 to 2. This is done. Now what we need to do? We need to join 2 with 3, removing this connection, and 3 with null pointer because the list is ending, right? So we end here. So this has to be null pointer. This color is fine. So this should be null PTR. Okay. So if you take a closer look, this is nothing but it's kind of a spiraling the situation this way around. So you're following a trajectory kind of this trajectory, right? And everything that lies here is what is connected. And you end with null value. So this is the type of, these are the arrows that we are having. Okay, right. That's just for visualization purposes. And 2 points to 3, and this 3 finally points to null. Cool. Our head is still at this position, right? So now we have a basic understanding of the problem, that from 1, 2, 3, 4 we require is 1, 4, 2, 3. Okay. Yeah. Okay. So now let's see how do we start thinking about solving this particular problem, and what are the things that we can, you know, take into accounts which may be required to solve this uh, particular problems. So first of all, what we see is, given in this 1, 2, 3, 4 thing, our head particularly starts from this point, right? This point, and the head moves. See, you can't, after one, you can't just directly go and encounter four. You can't just put your head here without traversing this and this, right? So we need to move our head to this position, then we need to again somehow start, we need to take a temporary head actually. अगर मान लो हम लोग हेड को करंट पोजीशन देते हैं, उसको ट्रैवर्स कराते कराते लास्ट तक लेके जाते हैं, then we need to continue again कि हेड को ट्रैवर्स करा के यहाँ पे लेके जाना, which is not possible to do, right? So this is a thing which we can't think of. You can't reverse in a single linked list. So we can't think of this particular solution. Now what we can think of, since we need the third index just after the zeroth index, getting my point? We need the third index. These are the indexes, okay? Don't get confused with the elements. We need third index just after zeroth index. Then we need the first index. Then we need the second index. So one thing that comes into my mind is there a data structure in which we can put this particular linked list, and so that we can directly access that particular thing, right? So in kind of array is one such data structure where you can directly at order of one time you can access the zeroth index, and the next moment you can access the third index, right? Array is one kind of data structure, and so is vectors. Okay, so one thing that pops up in my mind is, why not to have a vector, rather vector, oh, why not to have a vector that holds these particular list nodes, as it is in the lead code, list node, and I call it my list. Cool. And list nodes pointer, why? Because we are given a pointer here. Okay, so we'll put the all the addresses, all the pointers that points to that particular addresses here, and then we can directly access zeroth index को zero वाले pointer पे जो होगा, zero वाले place पे जो होगा zeroth index पे, मतलब क्या है कि अगर एक वेक्टर है ना, तो ये तो उसका जीरोथ प्लेस है, ये फर्स्ट प्लेस है, ये सेकंड पे है, थर्ड पे। यहाँ पे जो पॉइंटर आएगा, एक्चुअली आई एम टॉकिंग अबाउट द पॉइंटर that will point to the address of this particular thing, that is one, right? Address of one. How do I write address of this, but you get it, address of one. Okay, now this will contain address of two, this will contain address of three, this will contain the address of four actually here. Okay, you get my point, these are the addresses. Okay, addresses. So we can now quickly switch, right? We have a head here. अभी हम बोल सकते हैं कि भाई तुम क्या करो कि जो पहला पोजीशन है उसमें जीरोथ पोजीशन को डालो, जो सेकंड पोजीशन है उसमें थर्ड सब डालो। तो इसके लिए हम क्या कर सकते हैं कि हम लोग वापस से वो अपना टू पॉइंटर वाला कॉन्सेप्ट, एक पॉइंटर यहाँ पे फिक्स कर देते हैं, एक यहाँ पे फिक्स कर देते हैं, इसको इधर करेंगे और इसको इधर करेंगे। समझ रहे हो? और कब तक करेंगे? जब तक वो क्रॉस ना कर जाए, है ना? दिस विल मूव दिस साइड एंड दिस विल मूव दिस साइड. So this is the way we are going to tackle this particular problem. This is one such way. So let's see how we do that. Okay. First of all, one thing that comes in mind that if there is nothing in head, okay, then you just return. Cool. Since there is a void function, so we just return things. Okay. Now we make a vector as I told you. A vector list node pointer and call it my list. Okay. Now we had such vector. Okay. Now what we need to do is we need to push things into that vector first, right? So let's first have a list node pointer current that currently points to the head. Cool. Now while current is not equals to null, you can write either write current only CRR or not equals to null pointer. You can complete it. What do you need to do is you need to push back. What do we need to push back? The current, right? तुम उसको पुश बैक करोगे तो यहाँ पे क्या जा रहा है इसका एड्रेस उसके अंदर जा रहा है ठीक है और करंट असाइन करंट का नेक्स्ट वैल्यू सो दैट यू मूव करंट राइट तब तो एक एक करके हम सारे को क्या करेंगे वेक्टर के अंदर डालते जाएंगे ठीक है now we have everything inside the vector now what we need is we need two pointers one will be I equals to 0 and the other will be j equals to my list dot size right is it dot size or dot size minus 1 dot size minus 1 okay now while we have I that is smaller than j we will execute certain stuffs now what are these stuffs first of all what we'll do is माई लिस्ट के जो ith पोजीशन पे है दैट इज द 0th पोजीशन ये पर्टिकुलरली आई है अभी और ये j है माई लिस्ट के जो ith पोजीशन पे है उसके नेक्स्ट वैल्यू को ठीक है मतलब कि माई लिस्ट के 0th पोजीशन पे जो एड्रेस है दैट इज एड्रेस ऑफ 1 उसके नेक्स्ट वैल्यू को आई नीड टू मेक दिस राइट सो माई लिस्ट के jth पोजीशन पे ऐसा हो गया उसके बाद क्या करेंगे हमने क्या करना है आई को यहाँ पे लेके आना है देखो एज आई टोल्ड यू देयर आर थ्री ऑपरेशंस राइट फर्स्ट ऑफ ऑल वी कनेक्ट वी रिमूव दिस एंड वी कनेक्ट दिस सो दैट इज डन डन हियर ठीक है कि माई लिस्ट के जो ith पोजीशन पे है उसके नेक्स्ट को क्या करो माई लिस्ट के jth पोजीशन वाले को डालो jth वाले को ठीक है तो इससे तो हम लोग एक चीज कर रहे हैं कि यहाँ से हटा के इसको कनेक्ट किया अभी क्या है दूसरा चीज that we need to connect this back to this particular two right as I told you if you remember there are three operations removing this going this and connecting this so अभी इसके लिए i प्लस प्लस करेंगे हम लोग तो अभी हमारा i कहाँ पे होगा i यहाँ पे होगा ओके अभी i जब यहाँ पे आ चुका है तो what we'll do is my list j का नेक्स्ट ठीक है मतलब अभी क्या है फोर्थ के नेक्स्ट पे हमें टू चाहिए ना तो jth पोजीशन के नेक्स्ट वैल्यू पे क्या करो हैव दैट टू वाला थिंग माई लिस्ट का आई ith पोजीशन वाला ठीक है और फिर ये तो हो गया सारा चीज और फिर जे को भी तो पीछे लाना है तो जे माइनस माइनस अभी देखो ये सारे एक वाइल लूप में तो चलेगा बट देर इज वन कंसिडरेशन दैट वी नीड टू टेक कि if j is here you know if j is here and we execute this particular statement कि ith पोजीशन पे जो है उसके नेक्स्ट को jth पोजीशन वाले को डालो उसमें और फिर क्या करेंगे i प्लस प्लस इस बार जब हम लोग i प्लस प्लस करेंगे ना तो दिस i विल नाउ गो एंड सिट हियर ठीक है सो नाउ वी कांट डू दिस कि तुम jth वाले के बाद वाले को ith वाले पे डालो समझ रहे हो वो कोलाइड कर चुका है ऑलरेडी so we need to have a checker here कि if at certain point I is greater than or equals to j we need to break okay this is the checker we need to follow why because जब भी हम लोग i प्लस प्लस कर रहे हैं ना हो सकता है at a certain point कि हो सकता है at a certain point कि जो i है वो j से आगे निकल जाए या फिर j के पास आ जाए ठीक है तो जैसे ही इक्वल टू j होता है हम लोग को ब्रेक करना है और देन वी आर गुड टू गो राइट तो यहाँ पे हम लोग जैसे लिखे हैं वो सारी चीज यहाँ पे लिख देते हैं कि माई लिस्ट के ith पोजीशन के नेक्स्ट को माई लिस्ट के जेड पोजीशन पे डालो ये हो जाने के बाद i प्लस प्लस करो and we need to check if I is greater than equals to j. What do you do is you break. Cool. And then my list j के next को my list I को डालो और j माइनस, ठीक है। अभी एक चीज और देखना होगा हमने को कि अभी देखो ये वाला चीज तो कैरी ऑन हो रहा है कि यहाँ से हटाए यहाँ पे डाले, है ना। बट अगर ब्रेक किया तो इस वाले को हम लोग को वापस से नल पॉइंटर, लास्ट लास्ट वाला पॉइंटर शुड बी नल पॉइंटर, राइट। तो हमारा आई यहाँ पे है, जब आई यहाँ पे चला जाएगा तो इसके नेक्स्ट को क्या करना है, नल पॉइंटर बनाना है। सो यू नीड टू राइट हियर माय लिस्ट ऑफ आई के नेक्स्ट एलिमेंट को यू मेक नल, ठीक है। So this is one way of solving it. Let's see if it works. We have a vector of list node pointers, my list. Then you are having list node current is equals to on head particularly right now. Now while current is not equals to the null pointer, what I am doing is pushing it into this. And okay, there is a, yeah, this thing here. Okay, right. Now this list dot size minus one while I is less than j, my I के next को j पे डाला, I प्लस प्लस किया, while this happens you need to break and then you need to put कि I के जहाँ पे भी end कर रहा हो वहाँ पे null pointer, और else my list j के next पे my list of I डालने का है और j माइनस माइनस करने का है। ओके, ठीक है। अभी तो ये काम कर रहा है, आगे का देखते हैं थोड़ा। ओके, so this is accepted, right? Cool. Let's analyze the time complexity quickly. इसमें और better approaches है because let's check why. So see, first of all we have uh, these statements, these particularly take order of one because this has nothing to do and are single statements. But this particular while loop, that while current is not equals to null pointer, you are pushing everything into the vector, right? So this will take order of n actually. The size of the linked list is what will get pushed into the vector. Okay. Now since we are having two pointers, again this also takes order of n because it is traversing through all the pointers and is all the pointers of the particular vector, and hence it will change the position accordingly as we have written. So overall the time complexity here of this particular algorithm will be order of n. Okay, cool. But what about the space complexity? So if you're gonna check the space complexity, we are requiring a vector to put things, right? This is where the space complexity becomes order of n because of the same size. The input size is what is the size of vector that is required. So our space complexity will also become order of n here. Okay, this is what we can, you know, uh, optimize, right? So how do we optimize this particular thing? Let's check using recursion. What is the idea of recursion in this particular problem is कि हमारा जो ये वाला चीज है one then two then three, sorry what suddenly happened to my handwriting, I don't know, I'm sorry. So one then two three four, cool. Now what are we trying to do in this recursion approach is, first of all we will have one root here and one current here, ठीक है, और करंट को आगे बढ़ाते जाएंगे, ठीक है। जैसे ही करंट हमारा एंड पे पहुंचता है कि लाइक करंट एंड पे पहुंचने का क्या मतलब है कि करंट का जो नेक्स्ट है वो नल है, ठीक है, इसके बाद तो नल है ना। हाँ, तो जैसे ही यहाँ पे पहुंचता है when the recursion it falls back, और जब कॉल बैक्स होता है ना रिकर्शन में 1.2 सेकेंड, सेकेंड टू थर्ड, थर्ड टू फोर्थ, आफ्टर रिटर्निंग अ पर्टिकुलर वैल्यू, आफ्टर हिटिंग द बेस कंडीशन, it falls back, you know, this falls back to this falls back to this falls back to this, and finally you get a value that is returned, which is our answer, right? So regarding this only, whenever it starts to fall back, what we will start to do is we'll start connecting the root to the current values, ठीक है, and then we will start incrementing root, समझे? अभी जब जैसे ही रूट करंट एंड पे पहुंचा तो 4 हो गया, तो अभी 1 और 4 को करेंट कनेक्ट कनेक्ट कर दिए और रूट को बढ़ाते जाएंगे, रूट को बढ़ाएंगे, तो जैसे ही I'll code it and then it will be more visible that it will have 2 and this way 3, right? और इसके बाद तो हम लोग null pointer डाल ही देंगे, ठीक? So this is the last thing that we are gonna do for today, and the rest of the questions will be discussed in the uh, next classes. So you just have to see what I am currently doing. I'll call a function that is rec with head and head ka next. Why these? Because as I told you, we'll have root and current at the next position. So head is this and current is this, right? So ये भेजा और इसको हेड पे रिकॉर्ड किया, ठीक है, ये फाइनल वैल्यू जो हमारा मिलेगा वो होगा, ओके। अभी तो हमें एक चाहिए कि function. Function you can write inside public or inside private, that's your choice. It's better to write inside private because that even if that's not accessible outside the class, we don't have any issues, right? This will return a list node pointer. Why? Because we are recording it inside a head. Now what is head? Head is a list node pointer, so we need to record it inside a list node pointer that we have to return. And here we can name it root, list node pointer root, and list node pointer current, ठीक है, ये हुआ। अभी हमारा बेस केस क्या है कि करंट अगर जब भी करंट नोड नल पॉइंटर बन जाता है तब हमें रूट रिटर्न करना होगा, समझ रहे हो? मतलब यहाँ से उठ उठ के जब भी एंड पे आ गया, एंड पे खत्म हो गया, तो इट विल नाउ रिटर्न रूट, ठीक है, रिटर्न रूट, okay. Once this is done, what we are going to do is we are going to increment that particular current value, क्योंकि बेस केस पहुंचना है अभी तो होगा, और उसको रूट पे रिकॉर्ड करते हैं, तो रेक we have root as it is but current के जगह we are sending current का next वाला पार्ट, ठीक है, क्योंकि करंट को हम लोग मूव करा रहे हैं आगे की ओर, ओके। नाउ वी कैन हैव वन चेकर हियर कि अगर रूट भी नल पॉइंटर बनता है, वन सेकेंड, इक्वल्स टू null pointer, then we can return the particular root. और अगर ऐसा नहीं होता तो फिर हम क्या करेंगे, what we need to have is a list node, वो 3 ऑपरेशन जो हमने वहां किया ना पिछले बारी, कि यहाँ से हटाया, आई मीन वो जो 3 ऑपरेशन हमने किया कि ये 1 और 4 के, ये 1 और 2 के बीच कनेक्शन हटाना, 1 और 4 को ज्वाइन करना, और 4 और 2 के बीच कनेक्शन जोड़ना, ठीक है, यही अभी हम लोग यहाँ पे करेंगे। बट कैसे करेंगे, एक हम लोग टेम्पररी ये ले लेते हैं, क्या बोलते हैं इसको, द पॉइंटर ऑफ दैट पर्टिकुलर ऑफ अ पर्टिकुलर नोड, ठीक है, करंटली इनिशियलाइज it with null pointer. Now if root is equals to current, CUR in my case, or root is equals to current next equals to current, तब हम क्या करेंगे, करंट का नेक्स्ट जो है उन तो नल पॉइंटर बना देना, क्योंकि चीजें एंड हो गई वहां पे जाके, समझ रहे हो? अगर ऐसा कुछ वो वाला सिचुएशन है, ये वाला, कि अगर आई और जे हमने क्रॉस किया था तो हमने ये किया था ना, नल पॉइंटर बना दिया था, इट्स द सेम थिंग हियर, कि इफ रूट इज इक्वल्स टू करंट और रूट का नेक्स्ट इक्वल्स टू करंट, तो हम क्या करेंगे कि करंट के नेक्स्ट को नल पॉइंटर बना देंगे। और अगर ऐसा नहीं होता है, मतलब कि अगर ऐसा ना हो, तो अभी हम लोग टेम्पररी वैल्यू जो हमने पॉइंटर लिया है उसका यूज करके, नाउ माय टेम्प इज इक्वल्स टू जो रूट का नेक्स्ट वैल्यू है दैट इज 2 इन माय आर केस, वहां पे ये 2 को स्टोर किया अभी टेम्परेरी में, ठीक है। अभी अगला क्या करना है, 1 को 4 के साथ कनेक्ट करना है, राइट। सो रूट जो अभी फिलहाल 1 है, इसका नेक्स्ट विल बी इक्वल्स टू करेंट, राइट, क्योंकि वो रूट जो अभी फिलहाल 1 है और जो करंट जो कि लास्ट वाला पॉइंट पे ब्रीच करके रुकेगा, ठीक है, तो उसको उसको जोड़ना है। एंड एट द एंड वी नीड टू हैव इज करंट का नेक्स्ट वाले पॉइंटर को जो हमारे टेम्परेरी पॉइंटर पे है उस पे जोड़ना है। So currents next is equals to 10. This will be more evitable when we are like learning it through the recursion tree. Okay, so if you can draw your own recursion tree and just check कि क्या हो रहा है इस चीज में, ठीक है। देखो सबसे पहले क्या है, हेड सेंस रूट और रूट के जस्ट नेक्स्ट वाले एलिमेंट, मतलब हमारे केस में 1 और 2 भेजा, ठीक है। Now you forget about this point currently, it falls because this is not the case, so it falls out here. Now root is equals to rec of root and current connects, ठीक है। तो हमने क्या किया था, हमने फिलहाल भेजा था 1 और 2, ठीक है, रेक में। हाँ, ये पहला कॉल है, इसको यहाँ पे बनाओ, ये पहला कॉल हुआ। Where is the second call? Now root is equals to rec of root and current connects. So this is stored in a head, right? This is stored in head. अभी इसके बाद जो नेक्स्ट कॉल हमारा बन रहा है वो रूट पे बन रहा है, which is nothing but rec of 1 as it is, and then instead of 2 we send 3, right? We are sending 3, so it now again goes back here. Now it checks, now root is this particular thing. Now our next root will in this particular call will be rec of 1 comma 4. Cool, goes here. Now it checks whether it's null pointer. No, it's still 4, so it falls back here. Now root is equals to, now this says कि our root is equals to rec of 1 comma, this time it sends null क्योंकि 4 के बाद तो null है. So now when this condition is checked here in the next call, it says yes, the cur is equals to the null pointer. First of all, let's run it. Checking on it and let's say, where is the problem? You say expression is not assignable. Oh, oh, oh. Ah, let's submit and check. Okay, so this is accepted. Don't go at the runtime right now. We'll see. There is one more optimized algorithm that is much more better, which is reversing and merging. That we'll discuss in the next class. Till then, you can try it yourself. So this is the most optimal. But I need to give you the concept of recursion wala. So I'm telling this that, so now we are here. Okay. Now what happens that whenever this particular thing is checked, so it tells you that yes, root, that current is now equal to the null pointer. So it returns root. Now in this case, what is our root? That is 1, right? This is root and this is current connects, current actually. So now we return, we got 1. Okay. So now this is stored into this value, root. Okay. And now it falls back. Now our root is 1. Okay. So root is 1. So now it checks is root null point equals to null pointer? No. Then it takes a temporary, okay, if root equals to current. So in this case, there is nothing to do and it falls back. So you come here, right? You come here, then it checks whether root is equals to current. In this case, it's not, right? So we have this particular loop, okay? Whether the root, so root is 1 here. Actually, instead of writing it here, this returns 1, but what it does is it saves root as 1 here. Okay, root is equals to 1. ये वैल्यू यहाँ पे सेव हो गया, root equals to 1. तो अभी देखो यहाँ 1 जो root है तभी 1 है, is it equal to 4? No. Or is root का next equals to that particular 4? No. So we fall here and then we check temporary is root's next. So our temp is root, that is 1, and 1 का next क्या है? That is 2. Okay. Now root's next is equals to curse. So root का next, so 1 का next पे हम लोग CUR, that is 4 is what we are putting here. Okay. And then current के next पे we are putting this particular temporary 2. ठीक है, ये part यहाँ पे done होता है. ठीक है, और what we are returning temp, that is 2. So अभी यहाँ का वैल्यू जो है ये फॉल किया, इस बार 1 लेके आया था पिछले बार, इस बार 2 लेके आ रहा है. ठीक है, रूट का वैल्यू 2. So now we can check after this particular recursive statement, is it equals to the null pointer? No. So we have a temporary point. Is root equals to current? In this case, no. Is root का next equals to current? Check. 2 के बाद तो 3 ही आ रहा था. So yes, right? Yes. So what we need to do is current का next pointer equals to null pointer. That is 3 का next is equals to null. ठीक है, ये किया. Now wait, we'll have to connect this 3 here somewhere and then we'll put null. तो connection कहाँ पे है? Return temp. So return temp will return root connects. Root connects is 2. Okay, wait. We have 2 here, so our root value is 2, and we are checking this particular thing whether root is null pointer. No. Then we come up here that the pointer temp is assigned currently to the null. If root equals to current, that is not correct. But if root ka next equals to current, in this case it falls to true. Am I missing something? Yes. So current ka next is null pointer, that is okay. And then we return temporary, which is a null pointer. So here null should go. And this head should be null. No, it's not correct. Null can't go at this particular head position. I don't know whether if I've traced it back correctly, but there is somehow that 2 should be connected to 3 and then 3 will be going to a particular value null. I want you to just, make this particular this recursion tree and check yourself that things are happening. I'm missing it somewhere. But as I told you, ये recursion इसका जो value आएगा ना, आगे चलते जाएगा जब तक हमने कुछ return नहीं किया. In this case, we return 1, that falls back and we place that value inside this particular root. And then we follow the next statement that comes after the recursive statement. Okay. So I hope you guys can check it once there. Okay, and if you move on to the time complexity, so that will also be order of n. Why? Because this particular thing you see is traversing through every, you start from head and this, but this particular thing is traversing to every particular nodes that are present inside the linked list, right? So the time complexity is order of n. What is the space complexity? That is also order of n in this case, because we are using this particular uh, parts of that particular linked list, right? So how many parts we are using, that is equals to the number of inputs that we have. So it is nothing but order of n only, number of inputs. So this is it, and I think today we'll be ending it here, and we will check it in the next class, the next two questions. Okay, okay then. I hope you are checking the Notion and all stuffs, the notes that are being uploaded on Drive. Keep going through it if you want, and yes, good luck in your grind. Okay, bye bye.